Hello, here I'm about to do an exercise in complex variables suitable for years 17, 18 and above. Now, if x plus iy, where x and y are real, equals the hyperbolic tangent of u plus pi I upon 4, show that x squared plus y squared equals 1. So let the argument u plus pi I over 4 equal theta for convenience, and then hyperbolic tan of u plus pi I upon 4 equals hyperbolic tan of theta, which is sinh theta over cos theta. Okay, and since sinh theta is e to theta minus e to the minus theta over 2, and cos the same, except it's a plus e to the minus theta, when you divide them, the 2's in the denominator cancel out, so that comes down to e to the theta minus e to the minus theta over e to the theta plus e to the minus theta. And then multiplying top and bottom of that fraction by e to the theta, we get e to the 2 theta minus 1 over e to the 2 theta plus 1, which now substituting back for the theta gives us e to the 2u plus pi I over 2 minus 1 over the same thing, except the minus 1 is a plus 1. And then that equals to e to the 2u times e to the pi I over 2 minus 1, and the same in the bottom, except the minus 1 is a plus 1. And then using Dr. Euler's formula, we get e to the 2u bracket cos pi upon 2 minus plus I sine pi upon 2 and minus 1, and then the same on the bottom, except the minus 1 is a plus 1. And then that easily simplifies to minus 1 plus I e to the 2 over u divided by 1 plus I e to the 2 I e to the power 2u. And then multiplying top and bottom by the complex conjugate of the denominator. On the top we'll have minus 1 plus I e to the 2u bracket 1 minus I e to the 2u, and on the denominator 1 plus I e to the 2u bracket 1 minus I e to the 2u. And when you multiply out the top, that quite easily comes to minus 1 plus I e to the 2u plus I e to the 2u again, plus e to the 4u, and the denominator will be 1 plus e to the 4u. So x is the real part of that, and y the imaginary part. So x equals 4u minus 1. Say that again, x equals e to the 4u minus 1 divided by e to the 4u plus 1, and y equals 2e to the 2u over e to the 4u plus 1. And then squaring those and adding them, you'll have e to the 4u minus 1 all squared plus 4e to the 4u, and on the bottom will just be e to the 4u plus 1 all squared. The rest of it is just fairly straightforward algebra. We get e to the 8u minus 2e to the 4u plus 1 plus 4e to the 4u, and it's quite easy to see the top of that will be e to the 4u plus 1 all squared, and same as the bottom is e to the 4u plus 1 squared, which comes down to 1, which is what we were asked to do. And that does it. Thanks very much for listening.